Hello.
Yeah, doctor, we can hear you now. Hello? Okay, just sound cut.
I think Doctor has a voice problem.
We just heard hello and then the voice cut.
Hello. Hello. Hello.
We can see you, Doctor, but we can't hear you.
Tu dia. Hello. Ni kepala aku. Hello.
Hello, doctor.
Hello,
I
doctor.
already did until 3 exercise already. Suddenly, why no one is respond? So I was like, see the chat and then you cannot share me. Kau ada cepet ni, try. Tak ada eh? Kau ada? I have a computer also ni. Ini ha. C. Type C. Try lah. Microphone. Habis kau ada apa? Aku ada benda ni. Nah. Okay, sorry. Just now I already finished 3 exercise. Aduh, hai. Then no one is respond. So that's why I was like check. Why no one is talk to me? I was finish everything here until the example. So I already start from this slide until here. Now I need to start back. It is recording, right? Wait, I think if record, you can, yeah, you can see that I'm drawing, but you cannot hear my voice. I think.
Doctor, just now you didn't share the anything.
Please respond to me, not in the chat box. Direct inform me if there is anything happen. Okay.
No, doctor, we thought you are not
Start
talking or
again.
something.
Sorry, just now I just having, I have my class, but the microphone is work. But I don't know what happened. Okay. Yesterday we have taken a look into the Boolean expression. We already several time drawing logic circuit by using our Boolean expression. I already like using the simplest versions, which is, let's say I have AND gate. From this AND gate, from the very simple Boolean expression, I teach already how you can draw your logic circuit. So from here, let's say you have A. You have A input. This is your additions. It will be your OR gate. And you have P as input, next input. So from this very simple to quite very complex Boolean expression, you already know how to convert to logic circuit. And today you're going to learn vice versa, which is from logic circuit, you need to come up with your Boolean expressions. And also you need to learn on truth tables coming up from your logic Boolean logics expression, and from truth table to the Boolean expression. So over here you can see there is several things that you already knew it, which is I already explained several times. It is like our normal mathematics, same goes to Boolean to logic circuit. You can do the first thing using the factorize and the multiplication and then OR gate. And therefore, a draw circuit, you can see it says you can follow the same sequence. But for me myself, it's depend on you. You can see over here in these explanations, they teach you in several way. And me myself, I teach you in several way also. And here there is a step by step you can follow. Okay, from this example, last time I teach you on how to check this. If you're mathematical, you can do the factorize first. For the factorize, you can see here, you can solve inside the factorize first. But for me, you can also do from the beginning. You can see you have the dot here, which is in gate, going to have another in gate. You have the OR gate, and this one is this one is not gate. And then starting from here, I can see that I have A inputs, and I meet my AND gates here. From here, I have this boolean, and inside this factorized thing, I have B and C, and this is AND gate, and I will O is adding with my D gate. Sorry, D bar. And from here, I will end with this. But as mentioned, this is depend on your understanding how you can draw, and you can also follow the mathematical term, which is you do the factorize first. Okay, from here you can see this is your factorize. You're going to do this first, and next is your multiplication. So you solve this first. You have B and C. Multiplication is AND gate, and you meet the O gate with your bar. And from here, you solve the next outside solution, which is your AND gates. So this is the way you can follow otherwise. And in this slide also, it gives you example. You can make it each one as a single input. This one is AND gate between each others. So here you have B, C plus D bar. You make it to be, this will be N with the solution, which is all over here. And from here you have B and C. And this all solution, you have O gate, and you have D bar D, which is not gate. In a proper looks, you can see this. And how you're going to draw from this example, from starting from lower to up. You can see from this D, you have meet your node gate. And from this node, you're going to meet your O here. So your O, you have this between each other, which is your P and C. P and C and gate meet here. And you go upper, you're going to meet your AND gate with your A inputs. So either wise, it's depend on your understanding how you can draw. But basically, it's not too hard. And this is the example of the logic circuit. Now you have another example here. You can see first example you have, I'm going to show in terms of my way, okay? A here, I meet my A, and I meet with AND gate with my B bar. And from after that, I'm going to meet my O. And I meet the output for A bar. Oops. From A bar, I meet AND gate with my B. So in terms of mathematical way, the one that teach in this slide, you can do the normal mathematical form, which is first your multiplication here. You can see there is two multiplication. You do this first, you do this first, and then you're going to do for the second, which is additions. So let's take a look. A multiply with B bar. And second is your A bar multiply with your B. After that, you have the addition. Addition, you will meet your O gate. So this is your logic circuit from your Boolean expression. Second, from this, you can see you have A and you meet the AND gate and you have another input is your B. And you meet with the O gate. For this O gate, you have this another input which is node A, and it multiple with my B bar. And it will connect to the O gate. And after that, we have another one which is A bar. And it will multiply with my B and also another input which is C, and it will adding to my O gate, and this is my circuit. This is one way, as mentioned, that is my way how I'm going to draw, but you can also have an option to follow the mathematical, which is prioritize your multiplication first. Your multiplication got here A and B and A dot B. Second, you have A bar multiply with your D bar, B bar. The third one, which is A dot B dot C, A bar, and then dot B dot C. After you finish with multiplication, you're going to proceed with your addition. So you're going to add, you're going to add, you're going to add. So this is how you draw. For example number 3, we have the factorize here, so that's why we're going to do this first. From here, we have C add with my D bar. After this, we have the multiplications only for both. So we will multiply, but we solve this first, which is we have A bar and our B adding the multiplication, and here we're going to multiply also. So any question how to draw a circuit from a Boolean expression? Is it okay or not?
I think it's
Any
clear.
question?
No, doctor, it's clear.
You
No,
tak
Doctor,
dengar
it's
lagi
clear.
ke?
Ada suara.
Tak tolong
Ada suara,
jawab.
ada suara.
Hello.
Hello, doktor.
Hello, doktor.
Hai, you.
Hello,
Hello,
Tak
doktor.
dengar dia orang pula ke?
hello, doctor.
Hello.
Hello, doktor.
Aku tak dengar dia orang. Dia orang cakap.
Doctor, can you
Wait,
hear us?
Amel.
I
Okay.
don't think
I
so.
think now
Can.
Doctor cannot hear us.
Okay. Nice speaker problem.
Tak boleh. Tak dengar. Someone talk?
Hello,
Hello,
doctor.
doctor.
Hello, doctor.
Hello. Doctor, can you hear us? No, I can't. Tukar balik. Tukar mikrofon. Aduh, hai. Wait, microphone. Ayo. Kau jangan tutup mic.
Weh, terkejut aku. Hello?
Hello, doctor.
Yes, now I can hear you.
Okay.
I can hear.
Welcome back. Welcome back.
Doctor, just now you said you do the 3 exercise, right?
Yes.
At the front is the, if not wrong, is the De Morgan expression, right?
Yes.
Just now you didn't share screen, so we didn't have record about that.
Huh? This one, I didn't share screen.
Yeah.
Now also I didn't share screen.
Now got. Just now didn't have. The first time didn't have.
Oh, until which part?
When you realize your mic got sound,
Huh?
you just share the screen.
Ayo. This one, can you see this one? That
This all got.
Oh, you only cannot see the demogam.
Yeah, but we had done De Morgan yesterday.
Yeah, I think today I did not cover the demogam theorem.
Yeah.
I starting from this combination logic.
Oh, okay.
Okay. So this one also we already done right yesterday in your class.
Yes, doctor.
Yes, we do.
Okay. So now, sorry, there is a lot of trouble today. I don't know what happened. Everything is okay. Okay, let me continue.
Yeah, doctor, your mic just changed.
Now we're going to learn on if, let's say, we have a logic.
Doctor, can you hear me? Sky, can you hear the doctor?
No, we can't.
No,
I don't think any of
any
us can hear the
sound.
doctor.
Oh,
no sound
like I
already.
don't know what's wrong today. It's crazy.
Doctor, do you hear the sound?
She muted
Voice.
herself maybe by mistake.
But I didn't go to
Yeah. I don't know why. It's
Wait.
weird.
why it automatically mute? Tak, mute dia dekat sini. Padahal aku tak buka pun Google Meet. dah jangan tukar. Dah mana orang Bluetooth dulu. Ya Allahu Akbar. Kejap, aku buatkan. Sini. Mana apa setting? Aku on dia pergi kat kau. Aku on dia pergi kat kau. Yeah. Okay. Aduh, now you can hear me right? Ayu.
Yes,
Okay.
doctor, we
Yes,
can.
doctor.
Now let's learn how to get the Boolean expression from our logic circuit. Just now we learned on Boolean expression to get the logic circuit. So here we're going to come out our Boolean expression from a logic circuit. So this one is like also very easy for you to understand. Now we have number 1 here. We have C, and our N, which is dot. multiplication with our D. You can see here, C meet our multiplication and we have D, C dot D. And we meet with our addition. We add with our B. And we meet again with our N. We will multiply. Don't forget it is multiply all. And multiply with our A here. And this one, we meet the dot again. We dot with Z. So this is how you're going to come out your Boolean expression. And then you organize it to be very nice. You can also like having like A, Z, like this, B plus C, D. Okay, so let's say you have several example here. Let's take a look example number 1. For this part, we have C dot D bar. C dot D bar. And the output, we meet with our addition. Add with our B bar. The output, we meet with our dot. We put dot here. We will meet with our A. Now the output, we meet with our addition. From this addition, we meet another and here. But we cannot like directly put the and because this one is the input. So the input will be the input. A bar dot our B bar dot our C. So this will be adding. So that is our Boolean expression. Later you can also like simplify it and organize it to be look like very nice in terms of the Boolean expression. Now here can have another example. We have A dot B bar. A dot B bar. And we will have the output to be addition with our input of A dot B dot C, sorry, dot C dot with our D bar. And this one, we meet the addition. We add with another input, which is A dot B bar dot our C. So this is our Boolean expression for our X here. Next example, number C. We have C dot D bar. C dot D bar. And we meet with another dot. But don't forget, it's going to be like this. So then you can see it is all dot to be with another input. If you didn't put the factorize here, sometimes you might confuse later on. If let's say the example of like A plus B, and then you meet the N, and then you have like input D. So sometimes you misplace that, you assume this one will be B dot D. But it is basically A plus B dot D. Okay, so for here, we have the multiplication with our B bar. And the output, we will meet with the adding. For this adding here, what is our input here is A dot B bar. A dot B bar. So this is our Boolean expression here. Later you can like putting here to be nicer, A B bar plus B bar C D bar. Therefore here, question number D, we have A dot B bar. A dot B bar add with our input of A dot C dot D bar. So this is our expression for our Boolean expression. Later on, you can also like A B bar plus C D bar. This one also can. It's depend on their equation whether they want you to simplify or not. But this one just for you to see how you're going to convert from a logic circuit to a Boolean expression. Any question from this part?
It's all clear, Doctor.
Okay, thank you. So next we're going to learn how to get true table from our Boolean expression. Normally, we already take a look into it several times, especially when you have the very simple Boolean expression. What is it? This is your basic get. Let's say you have A dot B. Last time you learned AND gate and how the truth table look like. Zero 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 1 1 0 1 1. You have the output to be like this. If you still remember, this is how you get the Boolean expression to the truth table. From the truth table, you know how to get the Boolean expression. But of course, after this, you're going to have like very bigger in terms of the value of your input. That's why I mentioned you basically already learned how to draw the truth table from Boolean expression. But let's take a look into the very proper step. I already teach you that whenever you have inputs, it is your x here. If you still remember, I always said that to the power of your numbers of input. Let's say you have one input. So you're going to have the possibilities of 2. What is the combination possibilities, which is your input value? So let's say one input. What is the possibilities? Your gate not only get the input 1, which is you have possibilities. Let's say you have the input A and your output is F. Possibilities you will get 0 and 1 only, and your output will, Barbara toggle. So this is your possibilities, which is N. You have 2, but your X will be your how many inputs? If you have 2 inputs, you're going to put 2 to the power of 2, you get 4. What is this for? 0, 0, 0, 1, 1, 0, 1, 1. This one I already teach you last time. And if you, let's say you have 3 input, how to see the 3 input? Of course, in your Boolean expression, you're going to have like at least A, B, and C. Either it's going to be like this. You can see there is 3 input. This one we already learned. Also, how to calculate how many variables or input in our Boolean expression. So we have 3 input. Then we're going to have 2 the power of 3. And our n, which is possibilities of our inputs, we're going to get 8, which is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this is the possibilities. Altogether, I already mentioned to you from 0 to 7, altogether will be 8. And if you have 4 inputs, what you're going to get to the power of 4, you're going to get 16. So you might drawing it to be 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 01. Correct. 0110, 0111. And then you have, I continue, bisa 1000, 1001, 1010, 1100, 1101, 1111. So all together you have 16 from 0 to 15. This is 1111. If you convert to binary to decimal, you will get 15. And if you have you have 5 input, you're going to have 32 possibilities. Uh, 16, 62. Okay. Then you need to draw until 32. It also got last time in your final exam, if not mistaken, 4 and 5 input. So please make sure you know how to draw the truth table for that particular input, which is 4 and 5. Now from here, you have, let's say, example of F equal to AB. A, B. If you look here, oh, Doctor, this is all gate. I already remember how the output look like. It's going to be like this. Very easy. 0, 1, 1, 1. Because this is all gate. But how basically you can get 1 here. So the one output here, if you still remember your characteristic of your OR gate, you will get 1 if the value of A is 1 and the value of B or 1 or either one, right? So that's why you can see and check here for this state, you will get 1, this state we will get 1, this state we will get 1. So this one is easy because you already know it's already how to get the output. But if you have like more than not a simple basic get here or Boolean expression, how you going to get it? So that is a step by step. First step, you need to identify X and N, which is the total number of possibilities input that you're going to have, and also your value of your inputs. And step 2, find what will make your output become 1. Something like this, right? Just now we have A plus B. When you going to get 1 for your F? When? If let's say A is 1 or A is 0, and another condition if B is 1 and it will be 0, or both is a 1 1, right? So either one. So you need to name it what is the condition to make it 1. That is second step. Later, if you don't understand the sentences, we look into the example. Third step, from this, list in the table all and combination of 1, 0, which is you make it 1, 0, 0, 1, 1, 1, and so on. So you need to list all. And all the other output will be 0 after you have formed 1 for the condition. Let's take a look into the example. How to delete this first? Okay. We have F equal to A, B plus C, D. Now, first thing you're going to look into how many input you have. Okay, my input now, I have 4 input. And of course, I don't want to apply in this term of equation. I directly know it is 16. But of course, in your final exam or test, please do step by step because all step got marks. Especially you look into the marks, maybe the 6 marks. So you think by yourself, oh, which one got marks? Okay, I cannot come out directly the answer because the step got mark. It is not going to be like this is 2 mark. No. So this one is 1 mark, this is 1 mark, this is 1 mark. So total is like about 30 mark, 3 marks. So please make sure you do all step by step. Okay, now we have this 4 and all the positives will be 16. Let me try to draw it first. I have A, B, C, D. Muat ke ni? 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. Jauh hanya tertinggal. Silap. Wait let me delete. I need a space. That is the problem. A, B plus C, D. I need a space. Maybe I put here A, B, C, D. This is my F. Zero, 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 zero. Okay, this is all together my possibility inputs that I have 16 all together. And what is my output? So for the first step, you already done. You have 16 and you already draw the true table for the input and also the output. Second step, you need to know what makes your F to be 1. From here, you got A dot something, which is B plus CD. You know already for AND gate, your output will be only 1 if both is 1 and 1, isn't it? So A must be 1. You can see all other here is 0, 0, 0, 0, 0. Your output directly to be a 0. This is the possibilities for you to get 1, 1, 1, 1. But you need to check the condition of B, C, and D because you need to also got to be as a 1 here to make your F as a 1. Okay, now let's check our, this one is you done already, okay? This must be 1, so that's why the rest will be 0 until here. So your possibilities should be between this 1, 1, 1 for our input A. Now we have B plus C, D. We want it to be 1. And this is OR gate. You're going to get 1 if your B is 0 and CD will be 1. Or your B is 1 and your CD will be 0. Or you're going to have 1 and 1. All you will get 1, 1, 1. But if you have 0 and 0 for this and this, you will get 0. I think I'm going to find this first, which is I have 0 for my B. So my 0 for my B is only this part for this, and this. So let me have 0 for D, C and D. How to get 0 for C and D? If one input is 0, the rest will be 0. So I see this C will be 0, this D will be 0. I am going to get 0. 0, and then there is C as 0. Automatically will be 0. 0 for my B, but my C is 1. There is a possibility for my D? No, because this is AND gate. You need to have 1, 1 to be 1. But if you got 1, 0, you get 0, right? That's why you will get 0 here. Now for this part, you can see you will get C and D will be 1. So cannot apply the 0. You done with these 3. Now you can see there is a 0, 1, 1. For B, you can have the possibilities to get 1 until the rest here. But you need to check this condition, which is C dot D. This is the AND gate. You need to come out with 0 and 1 first over here, which is if B is 0, your C and D must 1. Then you will get 1 at your F here. This must be 1, this must be 1, then you'll get 1. If not, your B is 0, here is 0, you get 0. So here, let's take a look. This is my B as 0. My input C is 1, D is 1. That's why you will get 1 here. This is meet this condition. So you have the output as 1. So below here, you have B as 1. So after B as 1, you can see whether CD is 0 or 1, you still get 1. That's why for B as a 1, although you have 0 or 1, you will get 1, 1, 1, 1. You can see either your output input for C and D is 1 or 0, you will get 1 also. That's why you meet all these two conditions. This is your output. Directly, you can draw your truth table. If you do manually, how you going to do manually? If you do manually, you need to draw one by one, which is, let's say you have this A, B, C, D. You're going to have C dot D. After this, you have B plus CD. Then you have F, which is A dot B plus CD. From this C dot D, you need to refer D and C and D here. This is AND gate. What is your output? From this output, CD, you plus with your input B, you get the output. And then from this value, you do the addition, multiplication with A, which is AND gate. So you get your final output. So there is like manual way several times. But if you use this step, which is step 1, step 2, and step 3 here, this is step 3, you're going to get your final output directly. So it shows yours. This is much more beautiful if compared to my table. So you can see you have the step number 2. For A here, if A is 1, then you will get output of 1. If A is 0, totally you will get 0. You have the possibility to get 1 for the output if the A will be 1. So that's why the rest you will ignore and make it as a 0. You check another condition. What make B plus CD equal to 1? So these are 3 possibilities that you can make it as a 1. Now you still also have another one inside here. What makes CD equal to 1? So you need to have C and D 1 and 1 for this solution. Therefore, the output of A, B plus C will be, if A is 1, A is 1, B 1, C 0 or 1, D 1 or 0, you get 1. If B equal to 0, C 1, D 1, you get 1. So directly you will get the output. Any question from this part? You need to like slowly do it, then you can see more clear, I guess so.
Doctor, I have a question.
Hmm?
In this equation, CD is AND gate, right?
CD, yes,
Yes.
and get.
So the output must be 1 if both are 1, right?
Yes.
So how come in the bottom part of this truth table, like CD in the last four,
Okay, this one, you can see if, let's say, okay, this is the condition if B is 0. If B is 0, you need to get 1 for C and D, isn't it? To get 1. But if you need to have 1 and 1 for the C and D. But if your B is 1, it doesn't matter. You can see this one is 0, 0. You will get totally 0 here, right? But this is OR gate. You still get 1. This one plus with 0, you will get 1. Isn't it?
oh, okay, I get it
Mm.
now.
So any other question?
Yeah, I have a question, doctor.
Okay, yes.
Should we do step one every time we do any truth table, even if the question didn't ask?
This is very simple step. You just occupy maybe 5 seconds to do so. So it's better.
Okay,
so,
good, good.
so it's better for you to write down, because sometimes it's going to, in our marking scheme, we're going to have like marking scheme for each step. So for this step, we require like 1 mark, let's say. So it's better for you to write down. Okay.
Okay.
Doctor, this step just to show the numbers of output, right?
Yeah, that's true.
So can I just make it short and say 4 to the power 2 to the power 4 and instead of x and n and stuff like this?
Okay, for this also can, because we understand already the equation.
Okay.
So any other question? Okay, if there is no more question, we proceed to other next subtopic. You can see here. Okay, there is a tips for you. Tips on table marking. For n possibilities combination, which is the possibilities you have, the input part of the table will be registered in binary. This one. I think it is not a tip because I already informed all of you several times. You have 16 equal to 0 to 15, which is 0 until 15. If you have 3 input, eh, what is 4? I think it's 3. 0, 1, 2, 3. Okay, if you have 3 input, this one is 4 input. If you have 3 input, you until up here, then you will have 0 until 8. So this one is like a normal sequence that I already always shows you. So after you already done the logic circuit or the boolean, to the truth table. Now from the truth table, they give you the truth table. You need to come up with Boolean expression, and lastly, of course, after your Boolean expression, you need to come out for your logic circuit, right? So here you have the get the product term for high output, which is 1 only. Later on, don't make confused. Just focus that this is you want to learn how to draw the truth, draw the logic circuit from the table, because after this, I think the next subtopic or topic you're going to learn. Sometimes you might look into the zero output, because you're going to learn on SOP and POS. Like this one, this is like I forgot POS, I think. Or either one I already forgot. But if you have like X equal to A plus BC, and you have A, B, C, something like this, plus, you need to look into zero. So if let's say it's multiplication, you need to look into 1. So it later you will learn. But I don't want you to confuse. That's why I inform you directly now. Nanti if you learn the SOP, POS, you said, Doctor, why? Last time you mentioned just look into 1, but now why you need to look into 0 and etc. So I mentioned this is how you're going to learn from the table to logic circuit. So we focus first on this term, which is multiplication. Okay, now let's take a look on the step. First, get the product of term for output 1. So this is output 1. We have here from our truth table, of course, it is all 0 here. It is 1, 1. Then I want this to be my Boolean expression. How? From this truth table. Of course, you're not going to give you. Okay, it's directly give that just your truth table here. From this truth table, it's not mentions what is the Boolean expression. So from here, first find the 1. Okay, I got this 1. And from this, let me see what is the input. The input will be A, B, C. First, my A is 0, my B is 1, my C is 1. Second, my A is 1, my B is 0, my C is 0. So what is the meaning by this? This means you have A bar, because this is the value of 0. Normally, A is referred to 1, A bar is referred to 0. Normally, if you want to convert the value from two table to your Boolean expression. If you have 1 at your input B, is referred to B, and this one will be C, and this is all dot, dot, dot. As I mentioned, later on, if you tag the 0 here, you will have A plus B plus C, something like this. If you look into the 0, but I don't want you to be confused, but that's why I mentioned you will use this later on also. Okay, now you have another one, which is after you multiply all, going to add with another possibilities of 1, which is this condition 1, 0, 0. 1 will be remain as A, 0, 0, you will put the bar. So your Boolean expression from this truth table, you will get A bar B C plus my A B bar C bar. After I get this, now this is my answer. I have 0, 1, 1, 1, 0, 0. See? And this is my Boolean expression. From my Boolean expression, it's too easy. 1 minute you can draw. This one repetition from our previous recap things, which is you have, I do this first, A bar, adding multiplication with my D and my C. A, B, C. And this output will be OR with my another input, which is add multiplication, which is A. I have A here. Multiply with my B bar. And my C bar. Ding ding. I got 100% already. Any question from this slide?
Doctor, can you explain the POS and SOP again,
Oh, that
if you
one.
don't mind?
Okay, POS and SOP. I also can't remember. This one is SOP or POS. I think it is SOP. Yes. But later on, you're going to use this term in terms of the representations of your Boolean expression. You will learn on, I think, next module. And from this, if it is SOP, you need to see the output as 1. So from the output is 1. If POS, how the POS look like? Normally it's going to be like A bar plus B plus C and A plus B bar plus C bar. And from here, if you have this kind of Boolean expression, you need to look into this output of 0 and you refer to this one to get your value of your inputs. So this one, let's
Okay,
say,
doctor. Thank you.
so let's say you have output of 0, then you need to refer to the input. But for this one is your, you look into this input of output of 1. So that's why you will come up with the expressions of this dot and then there is adding. Okay, now you have another example. Okay, from this truth table. First thing, our first step, we're going to look into the scenario of 1. I have 3 scenario only. So it make me fasten my answer. My output is X. I have this condition. First condition, I will do very simple step. First, okay, A, B, C. 0, 1, 1. So my output will be A bar, B, and C. This is my 1. And second, I'm going to have still A, B, C, referring to this 1, 0, 1. So it will be represent as A, B bar, C. For my third one, it will be 1, 1, 0. So it will be A, B, and C bar. Why? As I mentioned, if it is 0, you're going to put bar. If it's 1, you will like copy paste the input. So my X will be A bar B C plus A B bar C bar plus A B C bar from this truth table. So second is my Boolean expression already come out. My third, which is drawing the circuit. So from here I have A bar multiply with my B and C. I have another A and then my B bar and my C bar. And from here I have Allah siratnya A and then my B and lastly my C bar. All these will be adding to my O gate. So that is very ugly. You can see this one. So you have this first step and second step, and this is your beautiful circuit if compared to mine. So from this example, is there any question? No question. So let me, kenapa ada student tarik diri? Okay, from logic circuit, the one by sorting, just now you learn truth table to logic circuit. Now from logic circuit, you're going to come up your truth table. Require only 2 simple steps. From circuit, you derive the Boolean expression. After output and the Boolean expression, you can get out the truth table. Very simple. Let's say you have this one. This is your circuit. Let me draw the ugly version one. W, X, Y, Z, and you have okay, from this circuit, you're going to see first you have AND gate, IND gate, and then you have OR gate here. AND gate here, what you're going to do, you have input W dot X dot with Y. This is one. And then over here you have Y dot with your Z. And this is just addition. W, X, Y plus Y, Z. This is your output G. From this, take a look into how many input that you have. You have input W, you have input X, you have input Y, you have input Z. And you have the output of your G. So how you going to get your truth table? From here, you can see you're going to have the possibilities of WXY 111 and YZ11. Then you will get your output as one. Tak cukup tempat, there is no space. Then you get this one, right? Because the truth table is here. You can see you will get G as 1 in term of W, X, Y. W1, XY, X1, and Y1. And term of YZ means that this is 1, this is 1. Then you will get your G as 1. It is too long. I cannot draw it. So you can see first of all, you have 1, 1, 1 for WXY. W X. Oops, not this one. W X Y is 1, and you can see also there is another possibility, which is WX1 is 1. It doesn't matter what is your X value, because as long as this meet 111, you will get 1 for your output. Next, you have Y and Z. Y and Z, 1 and 1. This is 1 and 1 for your Z. This one. So there is another, which is 1, and this is another 1. So why you said, why you ignore the rest of number? Basically, if you see this one, WXY, you still have the Z here, but the Z will be, alamak, I forgot already. Something like this will be 1, right? So either X and Y is 1, you will get also a 0, or 1, you will get also input as a 1. So that's why if you have like this, you just refer to that input. You doesn't care the rest. So if the rest is 0 or 1, it still got the 1. Is there any other example? No. So let's say we have a simple example. A, B plus B, C. This is my X. So we have 3 inputs. For 3 input, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. And my X here, A, B, C. If I have A and B as 1, Y is 1, because it is no bar. 1, 1, this is 1, 1, this is 1, 1. I'm going to get 1 for my X. For my B, C, I got B and C as 1. Only this and this part. Okay, that's why I have this. So my final truth table from my circuit, let's say, or my Boolean expression, I can directly get the truth table. If you have like this, I give the bar, okay? X equal to A bar B bar C plus A C bar. Ui. Okay. So what is the output for my truth table? I have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So where is my X? A, B, C. My X will be 0, 0, 1. Then I will get 1. For 0, 0, 1, I will get 1. And another one, if 1 for my A and 0 for my C. 1 for my A and 0 for my C, I will get 1. 1 for my A, 0 for my C, I will get 1. The rest will be 0. Then this is my output truth table. Any question? Because we finished already our module 4A. No question.
No.
Okay, good. Then we have another 30 more minutes. Let's play with our Jamboard. You need to follow your group last time. You got a group, right? I'm going to draw the question. Because my drawing is very ugly, I'm not going to share first. Let me draw it beautiful. Very simple one. A, B, then C, okay lah, simple only. So from the circuit, make the truth table, because you need to discuss, right? How many group? 6 group, right? So
Doctor, I think it's 7.
7 ah. Okay, I'm at 7. Okay, I'm going to share the Jamboard link for those who get the circuit already. You can start. What you need to do is you need to come out the truth table from the circuit that I draw. Follow the pages. Page number 1 is group 1, page number 2 is group 2, page number 3, and etc. Oops. Please, while waiting, please write down your team member name in all the pages, so then I know which group you are. Okay, done. Every groups already get their own circuit. You need to come out with your truth table. Okay, I think you can see group number 7, group number 6, 5, 4. Group number 3, where is your answer? 2 and 1.
Doctor, you're not sharing your screen, by the way.
Yeah, I'm just checking first. Uh,
Check.
Answer. Okay, in the chat board. Okay, I can see that most of you already understand, but I have several different answer, especially for the complicated circuit. This one. Also didn't check what is the answer. Let me try to solve it. Because you can see, some of you get only 0 for 0. Eh, why you draw 0, 0, 0 at bottom? And then you draw 1, 1, 1 and up. Okay, 0, 1, 1, 1, 1. Another version is 0, 0, 1, 1, 1, 1, 1. And so there is 2 group get the similar answer for this one. And this is the simplest. So the simplest version, I think, is not too hard. Let me try to change my colors. Green. Okay, let's say over here we have this as a solution. I think I got copy paste. Okay, we do the simplest one first. We have here A bar B. Here is C. And our answer will be A, B, C bar. Is it correct? So from this, when we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, we will get the output of 0, 1, 1 to be as a 1. 0, 1, 1 here as a 1. The rest will be a 0. This is A, B, C. So for those who get this one is correct, because I can see all of you answering the similar things. Let me check the much more complicated versions. Here we have A plus B. Here we got A bar C. And over here we will get A plus B plus with our A bar C. Right. So this is our final answer. From here, the one that I mentioned just now, later on you will see this part. But now we have A plus B plus A bar C. How you going to get the output? So we have A plus B, A bar C. From this one, we cannot directly go to the easiest thing that always we do. You can see over here, now we have A bar C. So for this part is easier because you have A dot C. you can find the solution to have 1 for 0 and 1. A, B, C, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So at least we have 0 for my A and C is 1, 0 and 1. I will get 1. So next is another input. It will be A plus B. So to make it to be like a multiplication here, I can times with my C plus. Okay, you can go to your rules over here if you want to simplify using the similar technique. A plus A bar equal to 1. So whatever numbers that you multiply with 1, your value is similar. That's why you multiply with this, you will get AC plus AC bar plus BC plus BC bar. And this one you already done. So whenever you have 1, 1 for A and C, you will get 1 for your F. You have 1, 0. This one is similar to this. And BC 1, 1, 1, 0, 0, 1. All of this will be have a 1 for the output. Why I do this? Because I want to use the 2 step just now. But for this, I can also doing the things that we just learned just now. Where is it? This part. The possibility and the step number 2, we can also come out with our solution for this part. If A is 1 and B is 1, whatever value is going to get a 1 also for your output. As long as B or A as a 1. So in any possibilities, you can get 1, 1, 1, 1. So that is from this side. But if you want to use the one that from this step, what we learn at our step number 1 and 2 here, what you need to do is you need to find the output of 1, right? That's why A and C is 1, you get 1. A 1 and C is 0, you get 1. B 1 and C 1, you get 1. B 1 and C 1. 1 0, 1 0, 1 0, you will get 1. Lastly 0 1. 0 1 and then 0 1 for C. 0 1. 0 1. 0 1 for C. This one is 1 0. Not yet. Okay. Now you have 1 1 1 1. How you get this is only 0. This is 1. Yes, you can get 1 plus 1 plus 0. You will get 1. And your C will be 0. You still get 1. Supposedly here also you get 1. Let me check my 1 0. 0. 1 0. Oh, here. 1 0. You get also 1. So this is the correct answer. I check some of you get correct, which is 2 group I think. So some you still didn't get correct. So please check again how you can convert from your circuit to truth table. Do you have any question related to this question?
Yes, doctor. Doctor, you didn't add the circle to the to the buffer gate.
This one.
Yes.
Then,
So we thought
okay.
it's buffer, not the
Oh,
reserve.
okay. Okay, this one is not get, not the buffer. Okay,
Okay.
sorry.
Okay. Thank you.
Any other question? So if there is no question, I think we can finish our class today. And this is your QR code. For those who already finished, you can leave. And thank you for your participant. Meet you again tomorrow. No, tomorrow only one session. Meet you again next week. Okay, bye bye.
Thank you, doctor.
Thank
Okay,
you.
thank you.
Thank you, doktor.
Thank you, doctor.
Thank you, doctor.
Thank you,
Okay,
Dad. Thank you, doctor.
thank
Thank
you.
you, doctor.
Thank you, doktor.
Okay, thank you.
Doctor, is there any update on the part B for like test one? Like, you know, my problem.
Last time you don't join the our extra class to solve the
Doctor,
solution.
like that day, they like the internet in our entire country was down for some reason. Like for like half an hour, and then I sat down to do all my assignments like early, but that was my bad, doctor. I completely forgot to keep WhatsApp on. So, doctor, i- is there like any way to fix that, or like do I need to forget about it? No, doctor, I can't hear you.